Today, we're getting into something pretty fundamental, actually.
Yeah. What do we got?
It's about what our littlest humans are encountering. We're talking bisphenol A, BPA.
Ah, BPA. Right. Always a topic.
Exactly. I've got a study here from PubMed. The title is Bisphenol A in Infant Urine and Baby Food Samples Among 9 to 15-month-olds.
Okay. Sounds specific.
It is. And our mission really is to unpack what it tells us about BPA exposure in babies around that age. Like, where's it coming from?
Makes sense. And BPA, just for a quick refresh.
Right, yeah, it's that chemical. You find it in some plastics, can linings. The big concern is it messes with hormones, potentially.
Especially worrying in infants during all that critical development.
Totally. So this study gives us a window into that.
And it's looking at that 9 to 15-month window, which is interesting. That's a big transition time, diet-wise.
From milk to solids, yeah.
Right. So these researchers in Korea, they looked at homemade baby food and urine samples. Gives you both sides what's going in and what the body's processing.
Okay, so let's dig into the study details. Who are the subjects?
They had 173 infants, Korean infants, and they checked in on them at 9 months, 12 months, and again at 15 months.
Oh, nice. So you can see changes over time.
Exactly. It lets you track if things shift as they get older, as their diet changes, that kind of stuff.
And what were they actually measuring? Not just yes or no for BPA.
Oh, no, much more detailed. They were measuring the concentration, how much BPA was actually there.
Gotcha.
They analyzed 210 samples of the homemade baby food and 187 urine samples. And they used some pretty serious tech.
Like?
For the urine, it was HPLC MSMS. For the food, GCMS.
Okay, alphabet soup.
Yeah.
Basically super sensitive tests.
Exactly. Think like finding a tiny, tiny needle in a huge haystack. They can measure really minuscule amounts. You need that precision for this kind of work.
Right. So these super sensitive tests, what did they turn up? Was BPA actually showing up frequently?
That's one of the big takeaways in the urine.
Yeah.
Very frequent.
How frequently?
Across all the age groups, 9, 12, 15 months, BPA was found above the limit of detection in about 85.5 to 85.7% of the urine samples.
Wow, 85%. That's a lot.
It really is. Limit of detection just means the level where the machines can reliably say, yep, it's here, and here's how much. So it suggests pretty widespread exposure in these babies.
Okay, that is high. What about the food they were eating, the homemade stuff? Was it just as common there?
The food was a bit different, more variable.
How so?
BPA was detected in, anywhere from 32.5% up to 76.3% of the food samples.
Huh, that's a big range.
It is. And that percentage seemed to change depending on the age group.
Ah, okay. Now we're getting to the really interesting bit, I think, the actual levels. Did they find a lot? A little? What were the numbers?
Right, the concentrations. So in the homemade baby food, the median level was 0.45 nanograms per gram.
Which sounds tiny.
It is tiny. But remember, that's the median, the middle value. The range went from basically nothing detectable up to over 5 nanograms per gram.
Okay, so some variation there, too. What about the urine levels?
In the urine, the median was 0.93 micrograms per liter. And when they adjusted it for specific gravity, which is just a way to account for how diluted the urine is, it was very similar, 0.94 micrograms per liter.
Right, that makes sense, to standardize it.
Exactly. And again, there was a range there, too, from below detection up to about 2.6 or 2.8 micrograms per liter.
Okay, so we have these numbers from this study. How do they stack up against what we already knew? Did the researchers compare them?
They did, yeah. And that's important context. They noted that the levels they found were generally comparable to, or maybe even a bit lower than, what other studies had reported previously for baby food and infant urine.
So not necessarily a huge spike compared to the past, then?
Seems that way, based on their comparison, which is, somewhat reassuring, I guess.
Yeah.
Still there, but maybe not skyrocketing.
You mentioned the levels in food varied by age group within the study. Did the urine levels follow the same pattern?
Ah, yes. This is where it gets really counterintuitive. They saw a significant increase in BPA concentrations in the baby food given to the 15-month-olds.
An increase. How much?
The median level jumped to 5.09 nanograms per gram at 15 months. Compare that to the 9-month-olds, where the median was below detection, and the 12-month-olds, where it was a 0.47 gram.
Wow. Okay. So older babies in this group seem to be getting more BPA in their food.
That's what the food analysis suggests, yes.
Which kind of makes sense. Maybe wider diet, different food prep, packaging. But, and this is the big question, right? Did their urine levels also go up at 15 months?
And that's the kicker. No.
No, they stayed the same.
Pretty much. Despite that clear jump in BPA in the food for the 15-month-olds, the BPA levels in their urine didn't significantly change across the 9, 12, and 15-month measurements. They were statistically stable.
Wait, that feels weird. More going in through food, but not more coming out or showing up in the urine. How does that work?
It is puzzling. The researchers tossed around some ideas.
Like what?
Well, one thought is about the type of food younger babies eat. Lots of purees, right? High water content.
Yeah. Fruits, veggies?
Maybe the BPA in those really watery foods isn't absorbed as efficiently. Or maybe it's just not the main source contributing to the overall internal dose reflected in the urine for those younger infants.
So even if it's in the puree, it might not be getting into their system as much, or other sources are more important at that age.
That's one possibility they raise. The food itself might not be the biggest driver of the internal dose, especially early on.
Okay, so if it's maybe not the weaning foods explaining the BPA in the younger baby's urine,
Mhm.
what else could it be? Did they suggest other sources?
They did. They basically said, look, there could be other pathways, maybe other dietary factors, things used in preparing or storing the food at home, maybe,
Mhm.
or even environmental exposure. BPA isn't just food packaging. It can be in dust, on some receipts, stuff like that.
Right, the thermal paper thing.
Exactly. So it kind of broadens the picture. It's not just about what's on the spoon, especially for the really little ones.
Mhm. Okay, this brings us to the why you should care part for everyone listening. Why do these findings, from this specific Korean study matter to you?
Well, big picture. BPA is an endocrine disruptor. We know that. And infants are just, well, uniquely vulnerable during development.
Their systems are still being built, basically.
Precisely. So understanding how and when they're exposed is really crucial for public health, for parents, just for general awareness.
And the surprising part here,
The surprising part, food BPA going up with age, but urine BPA staying flat, it kind of challenges our assumptions, doesn't it?
yeah, it makes you think twice about where it's all coming from, especially in those first months.
Exactly. It suggests we need to look beyond just the obvious food sources, particularly for the 9 and 12-month-olds.
Okay, so let's try and boil this down. Key takeaways from our deep dive today.
All right. Point 1. BPA was detected really often in infant urine, like over 85% of the time, so exposure seems common.
Got it. Widespread.
Point 2. It was also found in the homemade baby food, and the levels in the food increased as the babies got older, hitting a peak at 15 months.
Okay, more in food for older babies.
But, and this is the crucial point, 3, despite more BPA in the food for the 15-month-olds, the amount detected in their urine didn't significantly increase. It stayed pretty level across all 3 age groups.
So high levels in the youngest baby's urine, even when their food didn't show as much BPA yet. It's a bit of a head scratcher.
It definitely is.
Hmm.
And it leaves us with a final thought, something for you to chew on.
Lay it on us.
If the food route seems to become more prominent later, around 15 months, what else might be the main contributor to BPA levels in those younger infants, the 9 and 12-month-olds? What less obvious environmental sources or daily routines might be playing a bigger role than we think? Just shows the picture of instant BPA exposure is probably, more complex than just looking at their diet alone. There's more to uncover there.